Hello everyone, this is our second session as part of the SZ workshop, which is about the practical IEC 61850 for substation automation for engineers and technicians. So this is pre-recording number 2, and it's about power system automation architecture. Right, so what are the things to talk about? The first thing is, so previously I told you about the need for power system automation. I told you about the need for remote access. I told you about the IEDs, which are the intelligent electronic devices that can be hired in order to get remote access to the information and to send, transmit, and receive the information from point to point or point to multi-point in a number of different network topologies. This is what we have already discussed, right? So I'm just going to focus more on this 61850, the architecture, the foundations of that, and a little bit difference between this system and the conventional systems. So basically, when we say power system automation, there must be a system of communication network in between, either 61850 or anything else, so that you can exchange the information. As it says in here, at least you need to have one SCADA station, inclusive of the master station and a number of RTUs, or a number of PLCs, as we discussed before. Well, you have got a lot of choices available. Technical-wise, you have got a lot of choices available. But in terms of what's available in that area, in terms of what kind of comms network is available in that area, your choices could be different in terms of price. Therefore, the thing that you have to consider is that your design of system automation should be not only technically accepted, but also economically accepted. It should make sense, all right? So it's not like you just propose something technical which is perfect and 100% okay, but at the end of the day, it's very, very, very expensive, okay? So the client should be able to afford it. Now, in terms of the new concept that has led to the development and creation of 61850, well, what was the goal? One more time. The goal was to simplify the system automation. The goal was to reduce as much as possible the wirings and cablings and connections and I don't know, these kind of things. Marshalling boxes, termination boxes, things like that, just to save time, to save money, and to simplify things. So basically what happens is that these days you are doing that in your daily life. Just look at how you are doing things these days as opposed to what you were doing 10 years ago, 6, 7 years ago. These days, for whatever you have got, all the issues in your daily life, you have got an app. You have got an application. So what was previously done? Previously, download, install, download, things like this for each program. So after a while, you notice that your telephone, your iPad, your iPod, or I don't know, whatever, is running out of memory, your flash memory or something like that. So as a result of that, you needed to have a cool disk or something just to save all this information. Is that right? So all I'm saying is that these days it may not be the case. So you are using applications. In other words, you are linked to a network rather than downloading a lot of things separately. Rather than storing a lot of things on your device, you have got iCloud, for example. You have got applications for many different things to be downloaded and installed on your telephone, yes, but at the same time, you are not limited just to one function. You can download one app, but you will get access to many different things, from movies to videos to, I don't know, to DVDs, to music, to pictures, photos, a lot of things like that. You are not limited just to one function. You know what I'm saying, right? So this is what it is. This is the concept for 61850 as well. That is the modern automation system. In the context of 61850, those environments are called bay, are called level, are called functions, right? Therefore, rather than focusing on each, let's say, separate function, we are focusing on tools, on, let's say, accessories, on data patches, data packs, modules. So it's a modular system, right? So what are the three main modules of this system? One of them is what we call the process level, another one is the bay level, and another one is the station level. So at the process level, you have got direct contact with the field devices, such as VT, CT, circuit breaker or something, switchgear, all the equipment, temperature control, pressure control, frequency control, voltage control, current control, power frequency control, a lot of things like that. Motors, generators, compressors, transformers. Then, when it comes to bay level and station level, that is the time for you to think about protection and control. So as you can see in here, pretty much similar to a power network where you have got different buses, 132 kV bus, 66 kV bus, 33 kV bus, 11 kV bus. It is very similar in here. So you have got a number of buses, but you have got a station bus. You have got data bus, you have got comms bus. See, these are the things. And these buses, these clouds of information should be interconnected together. Like what? Like, okay, look at the bay level. You have got, for example, protection units, you have got control units or something like that. So these are the facilitators. That's why at the beginning I said these days, unlike previous years, we do not have a very definite meaning for a protection device or control device. We call it the IED. This IED can be used as a protection device, can be used as a control device, can be used as both. It can be SCADA based, it can be PLC based, it can be Ethernet based, it can be Profibus, Modbus based, or protocol based. There are a number of gateways into this thing. That is the meaning of 61850. So 61850 is using the most advanced technology, which is based on big packs and patches of information to be interconnected by means of a number of bays and levels and clouds of information. It is using LAN and WAN and things like this. That is the meaning of this structure for the automation system. So therefore, as you can see in here, the standard IEC 61850 supports the communication for all the functions being performed in a substation. Functions in a substation. So it will look at everything like a function. It doesn't matter whether it is control or protection or SCADA or what. It is looked at like a function. So what is the purpose? The purpose is interoperability. Free allocation of functions to devices, to IEDs. Well, I would like to allocate this task to this. Hey, mate, this is a protection relay, yes, but at the same time, it's an IED. So it does the metering, it does the measuring, it does the control, it does the protection, it does the communication, it does many different things. I would like to call it the IED. So therefore, what is the benefit of that? Access to all the data that is provided in a standardized way by the services of the standard. Excellent. So I can interconnect a huge system all over America, or I can connect America to Canada, or I can connect Canada and America to Europe, and things like these. Because of interoperability, because these IEDs can read each other, can access each other, can be connected to that cloud of information by means of many different gateways. It depends. What kind of signal is to be transferred? Is that a protection signal? Is that a control signal? Is that an image signal? Is that a voice signal? What is that? So that function could be different. But whatever it is part of that communication system. So that is the scope, to support the communication for all the functions being performed in a substation, all right? That is the scope. If someone asks what is IEC 61850, that's it. This is the standard that supports the communication for all the functions being performed in a substation. But if the other person asks what do you mean by function, as I said, well, function has got a very broad meaning. And the idea is to interconnect and interoperate the whole lot. So how you're going to achieve that? So it says this standard was developed to address the need for a more structured approach to the design of substation automation systems. Structured. So it's all about the structure. So you are going to reformat this system or substation automation. What do you mean? Reformat? Restructure? Yes. Like what? Like this, for example, separate data model from the method of communication. I don't care whether the method of communication is, I don't know, modem, telephone line, satellite, I don't know, fiber, whatever. That is the method of communication. It shouldn't affect the way I'm just going to model the data. I'm just going to segregate the data. I'm just going to put the data into different groups. I'm just going to allocate different tags to the data patches and packs. It shouldn't be affected and impacted by the method of communication. This is what we're going to achieve. So what are the tools? Tools? Well, it is more like it is based on LAN, WAN. Like what? Like Ethernet? Like TCP/IP? Could be totally based on Internet, which is TCP/IP or Ethernet. It depends. Right. Well, we have already done that in many other things. You just look around you. Everything is software-based, package-based, application-based. Look at the way you are using your plasma or digital TV. You are using router. You are using modem. You are using a lot of devices connected to your internet. You can connect a lot of different telephones and PCs and TVs and digital radios and a lot of different things to different routers. They can all see each other. You can remotely reconfigure the settings of your TV, the settings of your router, the settings of your server. That's exactly it, isn't it, right? So it is, you are doing that. You are not unfamiliar with the concept. On the contrary, you are quite familiar with the concept because you are doing it every day, but not for a substation. You are doing it for your own life, for your personal life. You are not doing it for a substation. The idea is we are going to do the same concept for the automation of a substation. Pretty much similar to what you're doing for your own daily tasks. Okay? That is the idea. So basically, very similar to the way, for example, your telephone by means of Bluetooth, for example, can get access into a network so that it can send an image or anything, music clip or anything, video clip, to your TV, and your TV can share it with your PC, and that PC can save the information on its memory, and then via another network share it with some other users in another country or something like that. See? It all starts from your iPhone, for example, right? You are standing in your place, you are somewhere in Europe, you are somewhere in Australia, you are somewhere in New Zealand, right? You are standing at a place online, you are taking some videos, you are sending it by means of Bluetooth or something to someone, and it's all shared all in advance, right? In seconds, it is shared. It finds its way from one bay to another bay, from one level to another level. That's exactly it. So some users may receive it instantly, some users may receive it after a little bit of delay. Why is that? Because of that method of communication. Because not everyone has been connected to those bays and levels by means of the same method of communication. They have got different methods of communication. But the concept is the same. So I'm just going to model the information. Model, what do you mean? Well, the status of what? Circuit breakers, for example, open, close, something, measurements. Measurements of what? Well, measurements of current, voltage, frequency, blah, 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 things like that. Settings of what? Settings of the relays, for example. Configuration of the system, like what? Like, well, what kind of bus bar configuration do you have? Is that single bus, double bus, main and reserve, main and transfer, break and a half, or what? So what kind of configuration is that? How many transformers do you have? 1, 2? If that's 2, are they running in parallel or not? So this is what we mean by configuration. Definitely SLD, single line diagram, and also all sorts of other information regarding, let's say, the SCADA RTUs, the PLCs, and the relays, and all sorts of things, the configurations of them. Therefore, from this discussion, we understand that the protocol or standard IEC 61850 should be consisted of a number of parts. One part is responsible for those models. Again, another term that we use in this context is object. Those functions, for example, are any of them are looked at like an object. Patches of data could be an object. So we look at every task like an object, and we just model that object, and we have got some defaults for the object models to be selected or to be customized. One part of that is somehow has to do with the SCADA communication, right? So that is part 7-2, for example. Some part of that has to do with time synchronization of the information between America, Australia, I don't know, Europe or something. So that is the real-time communication. Some of them has to do with mapping that modeling information into the rest of the network. Some part of that has to do with the communication network. What kind of network is that? Is that SCADA-based? Is that comms-based? Is that what? It has got testing, it has got system aspects of requirements, it has got system engineering and project management, data management. So that by itself is self-dependent. This system, this standard does not need any helper. But it does have a number of requirements, and those requirements have already been identified in different parts of this IEC 61850. For example, when it goes into functional requirements, that's part of parts 3 and 4 and 5. If it goes, for example, into abstract services, you are going to identify what kind of services. So remember, we have got objects and we have got services. So objects are connected together by means of different services. And you need to have an abstract of those services. That is the subject of part 7.2. And again, we have got different types of abstract services. Some part of that, which is the subject of part 7.3, goes with common data classes. So you are saying that not all the data is considered the same. You have got different classes for the data. This is what we call the CDC, or common data class. Another part of that, which is part 7.4, for example, has to do with abstraction of data objects. something like compatible logical node classes and data classes. So pretty much, again, similar to a power single line diagram where you have got branches and nodes. In here, again, you have got a number of nodes, but they are not power nodes. I'm not talking about voltage and current or something. I'm talking about data node. Okay? This is the meaning of that. And then you need to do the mapping of abstract data objects and services. You need to understand the mechanisms. You need to understand the algorithms. You need to understand the objects and services and then implement them. So that is the meaning of IEC 61850. You have got a substation, right? No matter how complicated is that substation, you need to be able first to analyze that substation, but in a different way. So far, the way you have understood is that, okay, this substation has got 2 line incomers, and then it's connected to a 132 kV bus. And now it's connected to 3 transformers, and now we have got bus tie circuit breakers, blah, 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 and the transformers are protected by differential relay supported and backed up by overcurrent earth fault or something. We have got 2, I don't know, circuit breakers at the 2 ends of the transformer, and then we have got the 33 kV bus, we have got the switchboard switchgear, 33 kV with 8 outgoing feeders. That's finished. That belongs to the past. As long as you are going to interpret this system electrical-wise, that's okay. Not automation-wise. It's not like that. It's not like that. You have to define a number of different services, a number of objects, a number of algorithms just for them to work together. That is the meaning of that. Well, we have got some other services like, for example, DMP3. Right? DMP3 is basically coming from America. 61850 is basically IEC, so it's more like European style. So as you can see in here, this 61850 is heavily dependent on LAN and WAN and profiles and objects and things like that. However, that the MP3 is more like you have got serial ports, you have got, I don't know, data links or things like this. So basically, the MP3, as it says in here, has its roots in the RTU, where byte efficiency for lower speed links is absolutely important, while this 61850 has its roots in LAN and WAN. So it is giving independent identities to what? To objects. Objects, yes, objects. So you need to understand the object. An object could be a transformer or could be part of the automation of the transformer. I'm not talking about a physical object. So this is system automation. This is substation automation. You should not naturally expect me to talk about the primary system. No, it's not like that. It is automation. So you should expect me to talk to you in regards to the signals and the delivery and dispatch of information, which is somehow related to that primary asset. Okay? But at the end of the day, this is a comms network. This is a system automation, something like this. So you can see that at the switchyard level, for example, you have got CTs, switches, VTs, merging units or wires or something like that. But the idea is this. The idea is to use a number of IEDs, which are multifunction, and I'm not saying exactly what they are. Is that microcontroller or I don't know, protection relay or what? I'm just calling them IEDs, and I'm just going to interrelate these IEDs by means of a number of IEC 61850 protocols. And let's say gateways, better say, a better word for that is that it can be done at process bus or level, it can be done at the station bus or level, It can be done at control bus or level, and then I can control the whole lot by means of a big WAN or LAN. Do you find it a problem? Yes. If that interconnectivity by WAN or LAN is damaged, you are losing the whole lot. As easy as that. You have selected that. Is that right? Previously, for example, you went to the market, you wanted to buy a hi-fi system. For example, you would like to have loudspeakers, amplifier, I don't know, things like that. You have got a TV, you would like to have a complete set of amplifier. Is that right? So you have got wire from loudspeaker number 1, wire from loudspeaker number 2, wires from woofer, subwoofer, or something like that, to the main unit, from the main unit to the TV or something. Well, okay. Is this good? Well, in terms of wiring, no. When you look at the back of your TV or something in your entertainment room, oh, mate, it's all wires and wires and wires, okay? So what is the new technology? New technology, you go to the market, can you see any wire? No. So how is it working? Wireless. Wireless? Yes. Well, so it is heavily dependent on a comms network? Yes. Something like Bluetooth? Yes. Something like internet? Yes. Something like router? Yes. So there is one way or another, is that right? So if it is wireless, there must be a network in between. But the question is this: if that network is damaged for any reason, if you have got a disruption of the internet, if you have got, I don't know, any problem with the router, then what? Then nothing. Everything's gone. Any backup? Nope. Can I listen to music? No. That's it. What about the old system? Yes. The wires have been damaged? Nope. It is firmly fixed. But you wanted to save money. You wanted to get rid of those wirings. You wanted to make it simpler. You wanted to provide interoperability. You wanted to be able to connect your TV to another TV or system thousands of kilometers away from here. That was you who made this decision. Is that right? Maybe that's not a good decision for a TV, but definitely it could be a good decision for a substation. Yes, when you think about it long term, you can save thousands, if not say millions of dollars of money because of all these simplifications, because of all this interoperability. Well, that's how it works, right? So you have to be aware of your decision. What is this decision? Is that a good decision? Some businesses, for your information, may decide not to migrate to 61850. Especially those with old systems. Oh, mate, so I'm just going to convert all this to 61850. It seems like, for example, you have got a wired network and you would like to make it all wireless. It's not as easy as that. You have to define a number of logics, a lot of logics, interconnections or something like that, because you're going to match this system to others. But if it is brand new, well, that's different. The design is easy. From the outset, that's fine. So the idea for the 61850 is to enrich the capabilities which are optimized for LAN WAN-based systems. As long as you have got that LAN WAN available, that's not a big issue. Something like this. So again, you can see from the top, you have got system network, you have got control network, you have got protection network. You have got process network. A lot of networks. So you're just simply going to connect these networks together. Whatever you can see in here is all objects. So you have to interconnect these objects, these patches of information, these functions, these services, mapped into this architecture, defined into this architecture, if you can, if you know the programming, if you have got the skills, of course. Not an easy job to do, of course, but you would love it, you would enjoy when it's been established. So therefore, as a way of comparison between that DMP3 and IEC 61850. DMP3 protocol specifies, defines the bytes, sent, received, data formats, and timing. However, this 61850 is based on mapping, profiles, objects, services. 61850 architecture is something like this. It is using LAN like Ethernet with different bytes, with different megabytes per second. It is using HMI, meters, relays, everything, but at the end of the day, we have got IEDs to be connected. As you can see in here, it's more like a gateway connected to internet. So if you lose that LAN or WAN or TCP IP internet or whatever that is in there as the gateway, if you lose that gateway, you can no longer get access to any of those levels or bays or something. And that's the risk. So when you look about a DMP3, for example, which is the older version, looks simpler, yes. But when you think about the 61850, it is more externally visible, all right? And it is more complicated, all right? So when you think about the, let's say, the features, there are a lot of features that we can define for this 61850. Like, for example, reduced setup, configuration, more interoperability, lower installation cost, reduced manual effort, errors, standardized device and object models, modern networking technology, standardized configuration language, object naming conventions, self-describing devices, more capability and flexibility, and things like that. A lot of things. So these are the benefits of 61850. As an example, again, you can have a look at this. For example, circuit, where you have got at the process level, you have got the, let's say, the switching devices, you have got the field devices, and then by means of a number of layers of IEC 61850 at different levels, at the process level, at the substation level, at the control level. They are not the same, right? The different levels. You can put a number of IEDs, for example, like PU or protection unit or CU control unit or something, just to get all of them connected together and then link them all to the HMI. So an example of that advanced automated system could be something like this, a combination of the relays and bay controllers and CTs and VTs, of course, modern ones like the fiber optic, like the optical ones, for example, modern switch gears again, not very old switch gears or something, so they can match themselves to this requirement. So what are the, okay, so now let's assume you are the designer of this system. You're going to design this. So what are the factors that can influence your decision, that can influence your design? The factors, for example, size of the substation. How many voltage levels do you have? Is that just 132 kV to 33? How many bays do you have? How many bus bars do you have? All right? How reliable and available are these voltages in your substation? Any bus coupler, circuit breaker, any redundant, for example, bus bar, any redundant transformer, what? How many substations you have got to be interconnected together? What is the life cycle of your system? How much of it has been left? Depending on how you're going to answer these questions, that will give you an indication to understand, okay, so if this is the case, well, I would like to have only one LAN, which is just single Ethernet, or no, I need to have a number of LANs, and they are not to be the same. For example, one of them could be LAN, another one could be TCP IP. One based totally on internet, another one not. That will tell you, depending on how much flexibility you would like to have, how modular you would like to design this, how you are going to put the panels next to each other, how you are going to interconnect the panels together, how many HMIs do you need to have, How many functions do you need to have for control and protection? But all I'm saying is that you have to look at everything like an object. Okay? A data object. You have to look at it like this. So when you have made all these decisions, so the final result is that you can finalize the number of cubicles, the number of bay computers, the functions of automations at bay and substation level. You can finalize this. And then you can configure the system to match what you want to have. So these are the things. So when you are doing this design, obviously you need to look at a number of functions. What are the main functions to look at, like interlocking, synchronism, for example, energizing check, or for example, breaker fail, or I don't know, zero voltage supervision or something like this, right? So these are a number of things, again, you can look at, but data-wise, not electrical-wise. Data-wise, you have to look at it. In other words, remember, don't forget, this is a system or substation automation system. It is not an electrical system. You already know the meaning of breaker. You already know the meaning of CT, VT, transformer, motor, generator. You already know that. I don't need to talk about that. You're going to automate it. So you need to get the very essential information and data that allows you to control this device, such as, for example, protection, such as synchronization, such as interlocking, such as supervision over a circuit. These are the things that would enable you to design such a substation automation system. While you are doing that, depending on the locations where this control is going to be done, time synchronization is important. Depending on the availability of the comms network, you should have that kind of a study in your design as well. Something like this. So when you think about automation architecture, we are thinking of this. For example, you have decided to have two LANs, not one, LAN A and LAN B, to be supplying the IEDs, all to be interoperating by means of 61850. And then, of course, you have got a time master, something like a time sync, which can be, for example, provided by means of a satellite controller. This is what we call the IRIC-B. And then, in terms of transferring the information, you can, for example, base it on also DMP3. So DMP3 serial port and 61850 also can match each other. You can look at them like red and green or something. There is no, let's say, conflict in between the two. It all depends how you're going to run your system, how you're going to automate your system. You can see that you have got, for example, old substations, you have got new substations, you have got local users, you have got remote users. Yeah? So you have got, for example, process buses, you have got servers, you have got admin users, you have got a number of different things, right? So they should be compatible, they should be able to work together. So from this end, I can nominate a number of architecture types. A very simple one could be architecture type 1, where you just give all this responsibility to one IED, which is connected to other. Let's say that IED is a very multifunction, modern protection relay, all right? It can be also connected to other protection relays and also metering. Is it good? So the inputs of CT, VT, something, and the output goes to the comms bus. And the whole information will be conveyed by means of a SCADA system. So it is what? It is IED based. This system, this architecture is IED based. Is that good? Well, yeah, in terms of simple wiring, in terms of integrated functions, in terms of easy fault location, in terms of peer-to-peer comms and things like that, yeah. And you don't need to load a lot of information on your microprocessors or something like that. Is it good? Yeah. But what about disadvantages? Disadvantage, you may have a total failure. Total failure, yes. If that IED fails, well, that's a total failure. And since you have put all that task on that same IED, that IED, the microprocessors of that will be high demand for the information. So you need to put a very high demand microprocessor, consider on the microprocessor. You have to strengthen that microprocessor. And of course, it has got limited IOs. How can I expand? How can I expand? How can I develop? Okay, so this time again, you have got that IED, let's say intelligent relay. It is again connected to other protection, but, and again, the output goes to a comms, but this time you have got also a bay controller. So it is not like you have put all those tasks on the shoulders of that intelligent relay. No, also bay controller is there. So a large amount of that information is saved and can be controlled from that way. It's more like you have opened up another gate. Advantages, so this time there is no total failure because you have got that controller as well. And of course, you can put a lot of information on the microprocessor of the controller, so less demand on microprocessors. Again, you have got peer-to-peer comms. Problem? Well, the problem, of course, is that since you have added another layer, it will be more complex. More load, it requires more space, more devices, more cost. That's how it is. So this up to here, it is protection-based. Your system is protection-based. Is there any other ways I can do it? Yes, I can combine that intelligent relay and controller together and add another comms processor. So this time it is comms-based, not protection-based. Is it good? Well, yeah, again, simple wiring, integrated reporting, easy fault location, space saving, more processor availability, but the problem, again, total failure, right? If you lose this, say, comms processor, you're finished, all right? So because it is comms-based, isn't it? If comms is gone, finish. Substation comms failure. High demand on processor, more wiring, and no full peer-to-peer comms. All right, so is there any other way? Yes, it can be SCADA-based. SCADA-based, yes. Again, I have got those IEDs and relays and everything, but this time everything is controlled via the RTUs, via the PLCs, and again connected to the comms bus. Advantages, yes, again, less demand on microprocessors and no total failure because this time the relay is not alone. But again, you will have more complex wiring and separate reporting and more space would be required. So basically, a very typical architecture of HV substation automated system could be, for example, something like this in very simple terms. Or it could be even something like that. So you have got multi-functions basically combined in one place. Or you can have something like redundant circuits as a means of separated maintenance and control architecture so that in terms of any fault or outage, you just replace one IED with another one, or you may decide basically rather than putting efforts on the IEDs, you just put your efforts on the buses, the data buses, on the network. You just make it redundant or something like that, double reserved or something. So there are many different ways you can improve your system. So definitely, when you think about the automation of MV substations, you can think of switchgear dimensions, number of bays, secondary equipment integration, bay equipment, network objects to be automated. So these are the tasks to be done. And obviously, it's going to be connected to a medium voltage network. At the beginning, when they design it, it is a meshed configuration. But after that, by means of switching or disconnect switches or something, load break switches, circuit breakers, it will be divided into a number of radial networks. So you should understand whether you are dealing with a radial network or with an interconnected or partly interconnected network. So therefore, you have to, one of the most important things to consider is that you would like to have now in terms of automation, would you like to have a centralized control system or decentralized control system? That's up to you. So centralized, more simple, everything is something like wireless, okay? But if you lose that center or centralized control, you're finished, okay? If it is decentralized, well, more wiring, more effort, not as user-friendly, but at least you are not going to lose everything. So this is an example of a decentralized control system. As you can see in here, yes, you have got your protection relays, you have got your control gears, you have got many different things in here, right? The HMI, the comms, and something like that. But it is not like everything is based on one thing. These guys are all injecting, receiving, transmitting to the same bus or different buses. So it is decentralized, but you can make it like this, centralized. So you can, for example, put your focus on a number of RTUs or just one RTU in here. So if you lose that RTU, in that case, that could be a very, very bad news. You can also apply this kind of concept into HV Bay control level, so you can see how these, for example, devices are interchanging and they are conveying the information between themselves, or it could be something like that along a number of feeders. Again, we are calling them bay control. Bay, okay? So that's data bay. So that data bay may relate back to feeder number 1 or to feeder number 2 or to the bus or something. So therefore, if someone asks you, what is the current trend in substation automation, you would say, well, at the moment, these systems are working together. So for example, we have got IEC 61850, we have got IEC 61107, we have got DMP3, we have got a lot of other things, and life is beautiful. They are all working together. But in the future, maybe in order to globalize this automation system, maybe not, maybe something like this. So everywhere you look is just IEC 61850, for example, or just sub-derivatives of that 61850. No DMP3, no Modbus, no Fieldbus, no Profibus, no nothing. Well, if you can achieve that, that'll be fine. But that's future. At the moment, it's not the case. But it is a possibility. All right, guys, I hope you have enjoyed this presentation with me. And I'm just going to present pre-recording number 3 after this. Thanks for listening to me, and see you next time. Goodbye.